Hello everyone, in this lecture we are going to learn about pipe support, a stress analyst POV, Part 2, example. This is Part 2, I hope you have already watched Part 1. Our flagship courses are Master Static Equipment Design, and PVE Light, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scutoid.thinkific.com.
So here we have an exercise. So let me just explain. There is one nozzle here. Piping is connected to nozzle. There are two nozzles, and the piping with some layout. That blue line is connected to this, and there is a layout given. The dimensions are given, and the axes are defined, X and Y axis. For the pipe material, alpha is designated here. And our task is to find out the displacement at point A in both X and Y directions. Our task is to find out the displacement at point A in both X and Y directions. The pipe material alpha is given, and the various dimensions are given. So considering the previous two rules of axial direction expansion and lateral direction expansion, we have to find out what is the displacement point of interest at point A. We have to find out what is the axial and lateral displacement at point A. Okay, so let us see. Well, the shortest distance of A first elbow is 1 meter. Then if you neglect the loop, which we have seen that it is a compensating leg, so we do not consider the lateral distances, and if you see only the axial distances, that is only 1 meter. And then from the second elbow to the point of interest A is another 1 meter. So total distance, the shortest distance of the point A from the anchor is going to be 3 meters. Okay. So our next point, the displacement of point B in Y direction. Now displacement of point B in Y direction will be forced by the leg which is connected to another nozzle. Now that another nozzle is at a distance of 2 meters from the elbow. So if you write down the equation of the expansion at point B, it is going to be L into alpha. So L, the length is 2 meters in that direction, Y direction, from the nozzle to the elbow, and the expansion coefficient is 1.8. So the distance of or the displacement of point B in Y direction is going to be 2 times 1.8. So that is 3.6 millimeter. So our next step. Now let us find the displacement of point B in the X direction. So now how do we find out this in the X direction? Point B in the X direction. So it is going to be our length, which is from anchor to the point B is total distance is 5 meters, and 5 into 1.8 is 9 millimeter. So the displacement of point B in X direction is going to be 9 millimeters. And now we have all the three parameters from this equation. We have the equation A upon B is equal to X upon Y. Let us fill up the values where the point of interest, the distance is 3 meters. The known displacement is at point B, which is 3.6 millimeters, and the distances are known. And if you fill up this, what is required is our distance, our displacement point X. So the X displacement is going to be, if you fill up this equation, you will find that it is 2.16 millimeters. So our main answer is going to be the displacement of point B in Y direction is 2.16 millimeters, and displacement of the same point in the X direction is 3 times 1.8, which is equal to 5.4 millimeter.
Launching of online live sessions on pipe stress analysis and Caeser II course.
So we are going to study a lot of theory which goes into the understanding of the problems that are going to be there. So what are the different types of loads that are going to be analyzed in the system, or the concept of the expansion and the strain. Then a very simple example which stresses the importance of the stress analysis, why we must carry out a stress analysis, and if we neglect the stress analysis, what are the complications or what are the effects that are going to be there. Then we are going to consider the evaluation of the stresses on the in the piping, and the types of stresses which we studied today, some types of stresses which are of a very basic nature, and we didn't go into the much depth of how they are derived, why they are going to be occurring like that. So we are going to study that in depth in our session. So then we are going to have some introduction to the piping codes. So when we are going to study in depth one piping code, which is going to be the most important, that is 31.3, from the point of view of various industries that are going to be using this piping. And we are going to show you how the 31.3, 31.1 is similar, or where it is going to be differing from 31.3. So we are going to see the similarities and the differences between the two, and we are going to study 31.3 in depth. So all the various chapters, right from 1 to 10, considering all the designs and materials, etc., we are going to see the essence of all these chapters which are going to be there. We are going to see the appendices, how the appendices, which are the important appendices for our day-to-day design works, and then how we are going to use that. We are going to do some calculations on the pipe thickness for internal pressure, then for external pressure, although it gives some reference to the ASME code, BPV code, but still for piping, there is going to be some limited application, and we are going to see only that part of the piping where we are going to use this external pressure thickness calculation. Then we are going to see the design check for pipe stub-in connection, RF pad requirements, miter thickness calculations, and various piping materials which are required in the industry for petrochemicals, chemical plants, and power plants. We are going to see why this code requirements are going to be there directly applicable to the stress analysis. So the piping code references with respect to the stress analysis, and the requirements of the code compliance, the theories of failure, the understanding of the complex stresses. We saw the allowable stress range, then displacement stress range, and we just saw the equations. And we did not go into the details of the derivation of the equations, or the concept of the calculations. And we are going to study in depth the displacement stress range, how those values of the bending stress and the torsional stress can be calculated, what is meant by the stress intensification factors, and how can we calculate with the help of the codes, various SIFs for stub-in connections, then flange connections, reducers, etc. So whatever different local changes are there in the stresses, how we are going to be considering that effect in the enhancement of the stresses which are generated in the piping system. Then after understanding this basic theory, we are going to study the various solutions which are going to be used for solving the problems related to the stresses, the strains, the higher loads in the piping system. So different solutions such as enhancing the flexibility, the application of the 4-bend, 6-bend loop, where 4-bend must be applied, where 6-bend cannot be used, or where 6-bend must be used. So all these studies we are going to make. Then what is the role of friction in the analysis? What is the concept of cold spring, the pre-stressing of the pipe, and how it is going to help in our analysis? Then limiting the values of the loads on the various equipment which are designed as per various standards like NEMA, API, or tank designs, the turbine designs, etc. That we are going to see the pump designs. So everything we are going to see, and how the limits can be achieved with the help of either directly the Caeser, or manually also, whether we can make this use to check and limit those values within the range. The other loadings that we are going to see are the PSV reactions, that is direct force, the wind reaction, that is the pressure force, and the seismic load, that is the acceleration loading, which is going to be there. And we are going to study how they are going to affect the already displaced system, and what are the limits of the stresses applicable, and why the system should be made safe in those cases also, and how it is going to be different from the flexible system, because a normal analysis requires a system to be flexible, but whenever we have a seismic or wind loading, we need the system to be more rigid. So how to achieve a balance between those two requirements and how to make the system safe for temperature as well as for loading such as occasional loading such as seismic and wind. Okay, good. Next. So then we are going to study in depth the piping supports and the restraints. So the restraints and the supports are going to play a very important role in the design of the piping system or the stress analysis of the piping system. So we are going to study the various types of supports from the construction point of view or the functional point of view, and how they are constructed at site. That also we are going to see. Then the use of the spring supports. Normal supports are going to be rigid supports, but occasionally we'll have to resort to some flexible supports like spring supports. And then in springs, there are two types. So which one to be used where, and how to make use of a vendor's catalog to select a required spring, because every time whatever the program gives, that is not going to be a final choice. And the user must be able to select springs on their own on few occasions, not every time, but sometimes there may be some applications where user must superimpose the requirement onto the software and design the springs accordingly. So we are going to study all such applications for the springs and the supports. Then going on to the Caesar, we are going to see the how to develop the Caesar modeling, how to model the basic pipes and various components of the pipes like T's and branch connections, reducers, walls, specialties, equipment modeling, the concept of connecting nodes, restraint modeling, and application of the wind loading, seismic loading, PSV forces, the concept of initial displacements when the tank settlement occurs. Most of you are aware of the tank settlements. So how to take the effect of the tank settlement into the analysis, that we are going to study. Then we are going to study the for modeling. There are various parameters which are going to be set before you really start on the modeling. So how to set the various parameters? There are hundreds of parameters which you need to study, and then only the actual modeling of the analysis starts. So we are going to study all those control parameters, the study, and then various effects of those control parameters, and how to change the drawing in the form of isometric on your table into the isometric which is understandable by the software, that is the Caesar. So for that we have certain method of node numbering, and to generate the model into the Caesar, that also we are going to see. We are going to see various options which are given by the software, such as copy, duplicate model, rotate model, delete the unwanted portion, copy from the previous project if there is some similar system. Then study some systems with the various temperature pressure effects. For example, there are various systems in the piping which are going to work in different ways of operations. So suppose we have some 4 or 5 pipes interconnected, then one pipe may be working at one time, another pipe may be not working at that time. So how to analyze, how to understand the operations of the system, and how to conclude this system's various temperature, pressure, and changes into the system, so that when you analyze the system, you will have only one solution. We cannot have different solutions for different operating conditions, and we must find out one solution for all the operating conditions. And we are going to study two such temperature cases. One is 2 temperature case, another is 3 temperature cases, which will make it abundantly clear to work on many more such systems. The software has got a facility to work up to 9 temperature pressure cases for one system. So we are going to study how to apply that technique to the analysis. Then we are going to study the modeling of the supports, the bellows. We are going to study make the flange checks. For example, a flange may also lead to a failure, because whenever the flange is there, it is supposed to be the most weakest joint in a piping system, and when heavy stresses are transmitting through the flange connections, then the flanges may open up, and the software has got a facility to find out whether there are any such cases, and we are going to study the flange checks. Then the nozzle flexibility is there, which we can superimpose onto the system to take advantage of the flexibility of nozzle connection with the equipment. then we are going to study the supporting from the equipment, because there are going to be many such equipment which are going to be used. For example, tall columns, where many of the piping which is dropping from the top to the bottom, it is supported from the column itself. So that effect is going to be totally different than the normal supports which are going to be resting rigidly on the structures. So we are going to study that, and then we are going to have a lot of advanced features also that we are going to study. For example, natural frequency calculation, then dynamic model analysis for pulsation, then dynamic analysis, seismic response spectrum analysis, force response spectrum analysis for slug and plug applications. So we are going to study such advanced cases also, which are generally not available in the industry for anybody to study. That we are going to cover that part also in our Caesar applications.
If you learn in community with a trainer who is guiding you, and it's a time bound. So 3 things will definitely help you to achieve. Okay. Achieve the result very fast, to accelerate your learnings. Okay. And apart from that, if you see 60% of overall project efforts comes from piping. Okay. 60 to 70% manpower is in piping. Okay. So it's definitely in very, very huge demand. And stress analysis among the piping group, almost 40% of the man hour goes into stress analysis. Now, okay, course will also talk about the layout related and overview of the course, which will definitely help you. Specifications, okay, stress analysis definitely in detail. So these things are very, very important for you to understand how piping behaves and how you will be able to work in this domain. Okay. So it's definitely covering 90% of your requirement of critical analysis. Whenever you are doing stress analysis or working as a role of stress analysis engineer, almost 90% of day-to-day work we are going to cover in this course. So that is really, really amazing. Now there are a few things like super advanced topic which may be used very little, but if you know, that will give you an edge. Okay, because those things very few people know about that. So definitely it's very, very important, and less data is also available on the net. So yes, very important. Okay, and definitely we will to cover refineries, petrochemical, power plants, all the different industries. Okay, great. So very good opportunity to upgrade yourself. So definitely, why not? Okay. So just to summarize how we are going to conduct this, it will be theory like we conducted right now, and it will follow with examples, live examples. We'll be doing the calculation together, and then software. So we'll be doing the same operation in the software. Okay, doing lots of modeling, analysis using Caeser II. The classroom will be live sessions, okay, online like we are doing right now. The duration will be 55 to 60 at least. Okay, it will run for 5 to 6 months. The course is starting from 3rd June. So still we have a month's time. Okay, and 8:30 p.m. same time when we are doing it right now. If the class will be conducted every Tuesday and Thursday. Okay, so 2 days in a week the class will be conducted. For some reason, if you miss out any class or you want to revise the concepts, okay, so this is a very important part. So it should not happen that you attended the class and then it's gone. Okay. So we are recording every class, editing and making it available as a e-learning course for you, so that you can view it even 1 year after you have attended the training program. So course duration after the session is ended. So if you think from the starting, so 1.6 years it will be available for you. Okay. And lots of study material, and definitely test will be conducted so that we are checking our progress. 1 year support with live Q&A will be provided once the course has ended. Okay. So till 1 year, whatever queries you are getting in your day-to-day work life, that will be solved with live sessions. Okay. And there will be WhatsApp community, which will be accessible for you for lifetime. You'll become part of that. You can ask questions. Trainer will be there. He'll be answering your question. You guys can also participate in the discussion. So community support, so that learning does not end. Okay? And you have somewhere to ask your doubts. Okay?
For in-depth training. And to learn more about these courses, register with the link in the description.